Good morning once again. I would invite Deepashri ma'am to start the session.
Good morning. Is my screen visible?
Yes, ma'am?
Is my screen visible?
Yes, ma'am, it is visible.
Okay. So I'm not doing the basic introduction for the periodic table. We have done a lot of times. So from yesterday's class, do anyone have any doubt? Anyone? Any doubt or anything? Okay. So we were doing this and we know how the Z star varies. We have done the ionic radii also. And okay, so we have done the ionic radii and we did up to this slide, like why the metal ions are smaller than the atoms from which they are actually formed. We explained the concept. So hopefully everyone remember this. Okay. A positive ion is thus always smaller than the corresponding atom, and more the electrons which are removed, the smaller the ion becomes. Obviously, this is something we yesterday did. Like there was a okay, so like there was the this is something the nucleus, different electrons were evolving, and we know in the nucleus, protons and neutrons are present, and surrounding electrons are present. Electrons, number of the electrons is equal to the number of the protons, and the electrons, if the electrons are being removed, then the number of the electrons will reduce because number of electrons and number of the protons are equal. One electron is removed, so number of the protons have increased. And that is the reason why we say that the positive ion charge has been increased. So this positivity increases the force of attraction on the electrons, and this full atom squeezes down and becomes even more smaller. And that is the reason we can say magnesium is the original atom. This is the largest in size. Magnesium 1 plus is smaller than this. Magnesium 2 plus is smaller than that. In exam, if they ask you x plus, x plus, so x will be here, x plus will be here, x plus will be here, x plus will be here. Hopefully this concept is clear to everyone. See, Fe2 plus, Fe3 plus. These are the two examples. So is this concept clear to everyone?
Yes, ma'am.
Okay. So the negative ion is always larger than the corresponding atom. Just the reverse case scenario. Suppose what is the negative ion? The negative ion is formed by the gain of one or more electrons. There is the nucleus surrounding are the different electrons. Number of the electrons are exactly same to the number of the neutrons, to the number of the protons. Okay, so now an external electron has come and has been added to a valence shell. So the number of the electrons have now exceeded, right? Than the number of the protons. So negative charge increases. So this positive charge cannot attract this negative charge because the negative charges are now not equal. Rather, these negative charges have now exceeded. So that there is the reason there is no attraction. And that is the reason there is no squeezing of the atom. And that is the reason it has been told that the size of this atom will increase. Okay, so this is the due to the increase in nuclear charge per electron, there is the expansion of the outer shell, size of the anion is increased. See, Oxygen 2 minus is larger than oxygen minus, which is larger than oxygen. Similarly, for iodine minus is larger than iodine, which is larger than iodine plus. This is the most important concept. This is the original atom. If it is losing electron, its size is decreasing. If it is gaining electron, its size is increasing. Okay, so is this part clear to everyone?
Yes, ma'am.
Okay, very good. So this can be explained on the basis of Z by E ratio. E is the number of electrons, Z is the nuclear charge. When Z by E ratio increases, size decreases. Okay, remember this. Z by E increases, size decreases, and when Z by E ratio decreases, the size increases. Just the reverse phenomena, Na, Na plus. So, Na for Z, Na is 11, E is 10. So it's 1.1. So Na plus 11 by 10, it is 1.1. Okay, so actually this phenomena happens, and that is the reason it's becoming 1.1. This is actually 11. So this should be actually more or less 9 by 10, not 11 by 10. Okay. So Na plus means loss of electron. Okay. So that happens. So actually Na plus, it should become 10.10 only. Okay. There is a mistake over here. Okay. So it should not be 1.0. Here it should be 1.1. While reading, make it 1.1. And this should be 10 by 10 because Na plus means one electron has been lost. So 10 by 10, here it should be 1. So 1 should be here, 1.1 should be here, and this should be 10. Did you make the correction? It has been written wrong. Okay, so did you make the correction?
Yes,
Yes,
ma'am.
ma'am.
Okay, so what I have told is that the Z by E ratio is inversely related. So here it is 1.1, here it is 1. 1.1 is greater than 1, and that is the reason what happens, the size will decrease. Okay, so for sodium, Na plus, that will be decreasing. Okay, so this will be the basic concept and how you calculate. Similarly for chlorine also, calculate and get the value. Okay, for isoelectronic species, the size decreases with an increase in atomic number. This is illustrated in the following table. See, now this table, see, this is oxygen 2 minus, F minus, neon, Na plus, Mg2 plus, and this is the basic concept. This is the basic atomic number. For oxygen 8, all are increasing by value of 1. Number of electrons here 10. Sodium has originally 11, but it has lost 1. So it has now become 10. Mg2 plus, it has 12, but it has lost 2 electrons. So 10. Z by E ratio is being here, and then automatically you can calculate the size. Just remember, if Z by E ratio increases, then the size decreases, and if the Z by E ratio decreases, then its size obviously increases. Okay, so H plus and CS plus are the smallest and the largest cations respectively. This is something fact-based question. H plus smallest, CS plus largest. Okay, see here. H minus, I minus, smallest and the largest ion. H plus, H minus, these are the smallest cation and the anion. And CS plus and I minus, these are the largest cation and the anion respectively. Is this part clear to everyone present here? Is this part clear? Okay. Ionization potential or ionization energy. What is this? So minimum amount of the energy which is required to remove the most loosely bound electron from an isolated atom in the gaseous state. See, minimum amount of the energy which you will be using to remove an electron in the gaseous state of an atom is known as the ionization potential or ionization energy or first ionization potential of the element. This minimum energy is spent, one electron is lost, and I told you if the electron is being lost, it becomes plus, original atom. Ionization potential, this is EV, which is calculated as ionization energy in joule and charge of the electron. It is 10 to the power minus 19, not 10 minus 19. It is 10 to the power minus 19. So from this slide, anything, any doubt?
No,
Anyone?
ma'am.
No. Okay. So they will be moving to this. Energy required to remove the second electron from the monovalent cation is called the second ionization potential. So this is one electron has been lost from the valence shell. Now we will lose another electron. So another electron is lost. So this becomes M2 plus and one electron is being lost. So that is thing. You can write M plus plus also. Okay, consider this is magnesium. Magnesium, this will happen. Magnesium, energy is given, one electron is lost, magnesium becomes plus one. Then again magnesium plus will lose another electron and magnesium becomes 2 plus. Okay, if you are writing electron in the right side, it means electron is being lost. If you are writing electron in the left side, it means electron is being accepted. Okay, similarly, we have third, fourth ionization potential like M2 plus. Okay, so M2 plus, then you have lost another electron, so becomes M plus plus plus. Okay, don't like don't get it confused with magnesium. This is just a normal metal M. To make you understand, I have considered it as an M. Okay, is this part clear? So, and what is this I2, I3? Here I have not written I1. This is the energy. This energy is the I1. Okay, here just to make you understand, this is the energy. I2, this is the I3. Okay, if you are writing anything above the arrow or in the left side of the arrow, it means they are being involved within the reaction. If you are writing anything on the right hand side of the reaction, it means that that thing has been eliminated. Okay, clear or not?
Yes, ma'am.
Okay, good. So see, M3 plus, then again some energy is being given. It forms M4 plus along with the loss of one electron. Okay, so electron, if you write here, it means electron will be accepted. Electron you have written here means electron has been given off. So it is observed I2 is higher than I1. So basically this is the rule. I4 is maximum, I3, I2, I1. Why? Because remember, amount of energy which is used by a metal to remove the most loosely bound electron is present in the outermost shell only. Remember from the Z star, as we are moving inner, the force of attraction is also increasing. So more amount of energy has to be spent. So I4 is more than I3, I2 and I1. If there is I5, then that will be greater. If there is I100, here it will be I100. So more you are spending energy to remove an electron from the innermost shell, more will be the energy spent. Is this part clear to each and everyone in this class or everyone is sleeping? Hmm?
Yes, sir. Yes, ma'am.
Okay. So the increase in the values of successive ionization potential can be explained on the basis that effective nuclear charge increases from this to this. Whatever I have said, like this is the out innermost shell, this is another shell, this is another shell, and this is the nucleus. Suppose you have removed one electron from the outermost shell, fine. Then you are removing electron from the second shell. Now it is more close to the attraction because it has greater Z star. Okay, so remember like this. That is force of attraction on the outermost electron towards nucleus increases. So obviously that is the thing. See, whatever you have read so far. Atomic size, larger atomic size, smaller the value of the ionization potential. Screening effect, higher screening effect, less is the value of ionic potential. Nuclear charge, ionization potential increases with the increase in nuclear charge. Penetration effect or shape of the orbital, speed, value of ionization potential for SPDF electron, it is the value of the ionization potential. See, for S is the innermost shell. So to remove an electron from the innermost shell, maximum amount of energy has to be produced. Right or wrong? So to remove electron from S, you have to produce maximum energy. So S greater than P greater than D, and F is the outermost shell. So minimum amount of energy you are using to remove an electron. Is this slide clear to everyone? Whatever I have taught so far, this is the summary slide. Okay, is this part clear to everyone? I have told
Yes,
that after reading each and every property, we will be summarizing what we have studied. And in the practice session, I will not give you anything like give the definition. I will just give you names of the atoms. You have to consider whether the ionic potential is high or not. If you are reading these notes and if you are practicing previous year question, 20 years, 30 years, whatever you can find in market, I can guarantee you in chemistry. Okay. So if an atom has fully filled or half-filled orbitals, that is, its ionization energy is higher than the expected normally from its position in the periodic table. Beryllium fully filled 2s orbital and N half-filled 2p orbitals have higher values than expected due to stable configuration. Who will explain me this concept? Tell me, who will explain me this concept? If an atom has fully filled or half-filled orbitals, its IE is higher than the expected normally from its position in the periodic table. See, this is explaining the ionization energy with respect to atomic orbitals. You can tell me that the atomic orbitals you have explained as the concept just now, that for to remove an electron from the s orbital, more energy has to be spent. So for s it will be higher than p, then d, then f. Then why this? See, so actually it states that atoms which have full-filled or half-filled orbitals have higher ionization energy than expected because of their stable configuration. Okay, like this is the exception only. Okay, see, this is what? S 5.4. This is S, but it is 9.3. Why? This is P 11.2. This is P 14.5. Nitrogen has a half-filled orbital. Okay, so half-filled 2p orbital. So it has a semi-stable configuration. Like in government job examination, there are two exams. One is the basic, then is the mains. So it has already cleared basic. This has already cleared uh, mains also, because beryllium has fulfilled orbitals, right? S can S can occupy, like not occupy, S can have maximum of 2 electrons, right? P can have maximum of 6 electrons. P already has 3 electrons here. So is this part clear? Beryllium has maximum of 2 electron. It is having also. So it is having a pure government job. It is on the verge of clearing the exam. Okay, so that is the reason. Though it has p orbital, but its ionization energy is higher. Okay, is this part clear? This is exception.
Yes.
Okay, exception. So variation of IE in a group. So force of attraction between electrons and nucleus decreases. Okay, and tendency to remove the valence electron increases. Hence, IE on moving down the group decreases. So down the group, its value is decreasing. In a period, it will increase. See, in a group, it is decreasing. In a period, it is increasing. ZE for ZE in period and group, both the properties remain same, both are increasing, but here one increases, one decreases. So if you are remembering the property name and its characteristic with respect to group or a period, so obviously for a period you don't have to remember the stuffs, you can remember with respect to group. Okay, the energies required to remove the subsequent electrons from the atom is known as the successive ionization energy. That I3, I4, I5, I2, those are the successive ionization energy. First, second, third ionization energy refers to the removal of first, second, third electron respectively. Then fourth electron, fifth electron. This slide should be given previously, but I guess you have already understood this slide. Second ionization energies are higher than first. We have already known. I4 greater than I5, greater than I3, then I2, then I1. So I2 is greater than I1. Why this happens? Because it is more you are moving inside, more force of attraction is increasing. Okay. So that is the C. Monovalent positive ion. After removing one electron, it is becoming monovalent positive ion, right or not? And we know monovalent positive ion has a strong attraction. So after removing the first electron, a strong field of attraction is being created. More energy has to be given to remove the second electron. So that is the basic concept. Is this part clear or everyone is just drowsy? This is the reason why I have explained to you why M plus is smaller in size than M, or M2 plus is smaller in size than M plus. Here that concept comes. So is this part clear to everyone?
Yes, ma'am.
Good. Okay. So next comes. Yeah, I can't hear you. So can you please write in the chat box? So this is the electron affinity. Electron affinity is what? Amount of energy released when an electron is added to an isolated gaseous atom to produce a monovalent anion is called the electron affinity or the first electron affinity. Like A plus E, which is the A minus plus of the energy. Okay, so amount of the energy which is released when electron is added So ionization energy, they are the amount of energy we are spending to remove. Now we are spending energy to add an electron. So that is the electron affinity. See, I have added electron in the left side. So electron is being added, so A minus plus energy. Most electrons have negative electron affinity. This means they do not require energy to gain an electron. Instead, they release the energy. Atoms more attracted to the extra electrons have a more negative electron affinity. Chlorine most strongly attracts the extra electrons. Radon most weakly attracts an extra electron. This is a fact-based question, remember this. So atoms are most attracted to extra electrons, obviously, because balanced charge. So if it can gain an extra electron, maybe it can be helping. Okay, so these are the poor people who attracts electrons because they have no electrons of their own. Noble gases are exception. They have positive electron affinities. Remember this. Okay, always. Electron affinities should be negative. I told you yesterday. If you are accepting electron, you become negative. Like you are asking someone for money. So respect for you in the society gets negative. Oh, she's poor, she's asking for money. So respect becomes negative. So electron affinity generally is negative, but noble gas is an exception. Okay, so noble gas are like the corrupted policemen. So they accept money, but nobody can tell them anything. Okay, so noble gases are like an corrupted policemen. For them, they have the positive electron affinities. Is this part clear?
Yeah, ma'am.
Okay, very good. Remember this type of examples. It will. So again, electron affinity, nuclear charge, electron affinity increase. Atomic size increases atomic size, electron affinity decreases. Electronic configuration, low. If you are asked to calculate electron affinity for beryllium or nitrogen compared to other elements, they will be low. Because if the element, the atom has full-filled or half-filled orbital, that value will decrease. Okay. See, here nitrogen goes to negative. This value decreases. Is this part clear to each and everyone present in here? Hmm?
Yes, ma'am. Clear, ma'am.
Okay, just once go through this slide, then you will understand what is the remaining. Electron affinities increases across the row. Row means, what is row? I forgot, what is row?
Period.
Yeah, very good, periods. So they decreases across period and decreases down a family. See here, the increases across the period and decreases down the group. These reasons I have written for your board exams. Why the electron affinities decreases across row or increases across row? State the correct statement and give a following reason to support your statement. Okay, these are the for that. For your competitive exam, what you need to know? Electron affinities increases across row in the periodic table and decreases down the family. This is how you read for competitive. Electron affinities are not limited to the element but also apply to molecules. For instance, electron affinity for benzene is positive. That of naphthalene near 0 and that of anthracene is positive. Is this part clear? This is a fact-based question. This is something for your board and joint. Very, very important. Frequently question comes from here. Okay. So this is electron affinities are not limited to the elements but also apply to molecules. For benzene positive, naphthalene 0, and that for anthracene positive. These are the different examples. I saw 2 times questions asking about electron affinity with respect to molecules, so I just added this. Okay. Again, successful electron affinity, same like ionization enthalpy, but here the reverse will happen than that of the ionization energy. Okay, electron affinity is ulta or the reverse for ionization energy. So obviously everything will be reverse for it. Okay, just read the concept once with your clear brain, write notes if you want to, and then read your notes. So here I have written so much why, just to explain you, so that maybe you are sleepy in class. When you are learning by heart, you don't get sleepy too much. Okay. Electronegativity, it is the tendency of an element to attract electron towards itself. So there we were adding electron. Here the nucleus is saying, no, 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 I want the electron, I want the electron. Okay, so suppose after exam also someone has kept you home jailed, right at the center. You have started protesting, no, 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 I want to meet my friend, I want him or her to come to my house. No, she has to come now. So that protesting nature of yours, that is the electronegativity. That is the measure of the tendency of an element to attract electron towards itself. See, electron is added in the left-hand side of the arrow. It means electron is added. I told you, if someone is gaining an electron, this becomes negative. But they all happen in gaseous state. Always remember this, they always happen in the gaseous state. If they are not, this question comes in Neet. Suppose they have given you 3, 4, 5 elements with A, B, C, D, E, and they have written solid, liquid. For them, the concept for electronegativity, ionization, enthalpy, electron affinity, this will not will be accepted. Is this part clear to all the fellow students here? Only for the gas. Okay, so sorry, I forgot to inform you about this before, but this is applicable only for gas.
Ma'am, once again, can you say?
Suppose in your exam, they have written A gas plus electron, A minus, which is I1, then A solid plus electron, A minus, which is I2. I2 is invalid. Why? Because I have told A is a solid. So if it is solid or liquid, these concepts will not be applicable. These concepts are applicable only for gases. Okay.
Yes, ma'am. Thank you.
Okay. Did you sleep suddenly? You asked me. It's okay. Okay. What is electronegativity? Tendency of an atom, that protesting nature of yours. No, bring that electron, bring my friend over here. Tendency of the atom to attract the bonding pair towards itself is the electronegativity. You have heard the term, oh, oxygen is more electronegative than hydrogen. Means oxygen has more power to attract the electrons towards itself. Suppose you are present in class and I am present in class. Okay, we two are friends. Now after exam, your urge to play with your friend is more than me. So you are saying, no, I want to meet my friend at any cost now. I have studied, I have given exam. So exams over, everything's over. Now I will be meeting my friends. Your parents did rebuke you, but you continued protesting. But my parents rebuked me, I have stopped. So you have a greater urge to meet your friend now. So your electronegativity is higher than mine. Okay, so your tendency to attract the bonded pair of electron towards yourself is more than mine. So you are more electronegative than me. Okay. So A into B, suppose this is A is you and B is me. Okay. So what you are doing, you are, suppose we are siblings here. Okay. Now understand a different concept. How many of you have siblings here? And siblings mean someone who fights with your siblings over a piece of chocolate or ice cream. How many of you have this kind of siblings in your home? Then you can relate to it. Okay, so suppose this is you and this is me. Not me, this is your sibling. Okay, and there is one piece of ice cream. You are comparatively weaker than your sibling. Now, your sibling has more power to attract that ice cream. How? Because your sibling can beat you, kill you, can do whatever with you to get that last piece of ice cream. Because he or she is stronger than you. So, whatever the ice cream should be equally shared between two. Ice cream. Okay, but now B is stronger. B is saying, no, I have completed my ice cream, I will be eating your ice cream also. I will beat you and do whatever with you. I want this ice cream. So B will snatch away the ice cream from A. See, so B has gained a negative reputation because B has now two ice creams, two lone pair. We don't draw the lone pair, but B has two electrons here. Okay, just imagine two electrons here. A has 0, and thus B has gained a negative reputation at B, that it can't, that it is fighting for a piece of ice cream. So this is D minus. A has a positive impact, that it has lost, it is gaining sympathy. See, it is D plus. Okay, so is this concept clear? What is electronegativity and what happens when a more electronegative element like your sibling is attached to a less electronegative element like you? Is this part clear?
Yeah, ma'am.
Okay, so this is something that happens. So atoms, electrons are just like us. They have, if they eat too much, they become fat. If they don't eat, they become skinny. There is a normal standard size. Even they fight with their siblings. Even they have parents to guard them during exams. See, everything is like us only. So arbitrary value of 4 has been assigned to fluorine. Why? Because it is said fluorine has electronegativity of uh, 4. It is just an arbitrary value. And this is the real value to calculate an electronegativity of two atoms. If you are studying chemistry in future, maybe you will not, you will be using this formula. But since we all are kids now, we are newbies, we will just say, okay, fluorine has electronegativity of 4. Write in your copy, fluorine, F greater than O greater than N is equal to chlorine greater than carbon greater than hydrogen. Have you written, everyone? Written. Everyone written or not?
Yes, ma'am.
Okay. Below fluorine, like below F, write 4. Below oxygen, write 3.5. Below nitrogen, write 3. Like nitrogen is equal to chlorine, I have written, right? So they both are 3. Okay. Then comes carbon. Carbon is 2.5. Hydrogen is 2.1. This is something you have to remember. Always remember, if they are asking you who is more electronegative, follow this chart. You can't do this calculation. This calculation is huge. Pauling scale. This is why I have written this, because they will ask in your boards. I have never seen they asking you stuffs like this in year exam. Maybe they ask you the formula. Okay, so this is something important for boards. But whatever I am telling you, that is important for your joint, Neet. And you can tell me out of all the elements why you told me about these elements, because only these elements will come only. If they are not going too much out of the box compared to the previous years, then obviously they will consider these elements only: fluorine, oxygen, nitrogen, chlorine, carbon, hydrogen. Okay, so if they ask you what is the electronegativity of oxygen with respect to nitrogen, it is more or less. See the chart and say. See the chart and say. Oxygen more electronegative than nitrogen or less electronegative than nitrogen?
Ma'am, can you repeat the question once again?
See the chart, whatever chart you have written, and then tell me oxygen is more electronegative than nitrogen, or nitrogen is more electronegative than oxygen. Just,
Oxygen, madam,
yeah,
have
good. Yeah, what is the value for oxygen?
3.5.
Yeah, that is 3.5 is greater than 3. Rest of you are sleeping or what? So 3.5 is greater than 3. So oxygen is more electronegative than nitrogen. Is this part clear? So just follow this rule, because you will be doing chemical coordination. Next chapter is the chemical coordination, I guess. So for there also you will need a lot of things like this. Okay, wait, my laptop hanged. Wait. Okay, so these are the different formulas you can learn. This is completely for your board. Allet, Rothschild scale, then Pauling scale. Okay, so these are, remember, Pauling scale is used to measure the solvation energy. What energy? Solvation energy. SOLVATION. This comes in your exam. Exam means Neet. Okay, they can give you match and join. And if you see Pauling's electronegativity scale, you can see solvation energy, just match them. What is Pauling's, what is solvation energy, you don't have to remember. Okay, so these are the different other formulas. If you can remember, it's fine. Allet, Rothschild electronegativity scale. If you can't remember, then also it's fine. So electronegativity trends, these are very important. Each element has a characteristics electronegativity ranging from 0 to 4. What I have taught you on the Pauling scale. How you are getting that value? If you are quite interested, you can calculate for nitrogen or for hydrogen or whatever you feel like. So the most strongly electronegative element is fluorine. See the chart has a value of 4. So electronegativity of 3.98, which we consider it as 4. Weakly electronegative elements such as lithium has value close to 1. Okay. Least electronegative is francium. It has a value of 0.7. And in general, electronegativity decreases down each group, increases across the period. Okay, so this is something fact, and this is very much important for your Neet boards, whatever, because they have a very less probability of asking you the definition. Rather, they will be asking you stuffs like this. Across period, non-metals tend to gain electrons and metals tend to lose them. Atoms are striving to achieve a stable octet. Down the group, nuclear charge less affected. This is the reason why in the period you can see it is increasing, and why in a group you are seeing decreasing. This again, it is important for boards. Okay. So the atomic radii decreases down the periodic table, ionization energy increases. So why we are studying electronegativity? Because the nature of the bond can be predicted. Okay. So which bond is covalent, which bond is not. If you are taking chemistry honors in future, you will be learning about this. Suppose fluorine, oxygen. Suppose fluorine is 4, right? And oxygen is 3.5. So fluorine bonded with oxygen will give you a value of 0.5. Okay, so this 0.5 will actually tell you whether the bond between them is covalent or not. This is not present in your syllabus, but if you are taking chemistry honors, biochemistry or whatever, you will be learning that. So difference is small, the bond is polar covalent. So there are different values. I don't exactly remember the values. I have read a long time back. So if you are calculating the values are purely covalent. And if you are learning these values, then it is polar covalent. So there is a chart. So there is, if the value is 1.7, bond is 50% covalent, 50% ionic. And if the difference is very high, bond is more ionic, less covalent. Okay. So this is basic thing you will be learning. Greater the value, greater will be the stability of the bond. Stability decreases. See, as the value is increasing, more stable. As the value decreasing, less stable. You have to remember these key points because they, in your NEET, they will be asking you HF, HCl, HBr, HI. Which bond is the strongest? You have to, like you can obviously ask me, ma'am, how can we remember so many characteristics? Just by practice. Practice previous year questions, and when you will be seeing the answers, that okay, so this I made wrong. Why? Because I forgot about this trend. So this is the reason. More mistakes you are making during the practice session, more better results you will be expecting in your original exam. Okay. Why? Because I'm saying this, because if you're making a question correct, you obviously won't remember that question. Oh, I have done this correct. Why do I need to remember? Okay. But if you have made the mistake, you at the back of the mind will think, I am still making this mistake. I am still making this mistake. When will I, like, you will have a tension. So that tension is good for your health. Not obviously health, but for your exam. Okay. So that is the thing. So more practice you do. Today, after ending the class, I will be giving you some questions. Try to solve this. Okay. So today we will be ending the periodic table, and then I know no one will do this, so I have done this for you. Ionic potential along period increases, down group decreases. Because why I have done all these characteristics in one page, one single page, more you see this, more it will be easy for you to remember. Is this part clear? Now you will just, now in your exam, what you are studying, you are not even studying the reasons also. I have made them short also for you. You are just learning what is ionization potential, along period increases, down group decreases. Okay, if there is any exception or not. Okay, and that chart is important with respect to atomic radii, with respect to Z star, how ionization potential varies. Bas, ionization potential is done. Then you are studying electron affinity. Then you are studying electronegativity. First time you will be studying, it will take you 1.5 hour, I know. Second time you are studying, you will know what to study, what not to study. And if you are a regular student who studies regularly, obviously you won't be taking more point. Okay, and these are some of the extra points I have given. Like melting point increases across period and decreases down the group. This total part will never come for your board. Okay, this total part will be very much asked for your NEET. If you have ever seen a NEET question paper, you will see they will give you a metal name or they will give you a compound name. What is the melting point? What is the boiling point? Do you think students really memorize the melting and boiling points of everything? No. So this is the reason I have mentioned what happens along period, what happens down the group. For suppose H2O, CO2, see, all have oxygen. So then you need to compare with hydrogen and carbon, which is where placed in the periodic table, and accordingly you have to solve. Okay, so these are the different characteristics. So this is the overall periodic table. Now uh today's class it's done. So tomorrow's class maybe I will be giving you some questions, some previous year questions or some questions I am making. You have to solve those questions. You can refer the PPT or the notes you have taken and then start solving the questions. Is this part clear? The whole of periodic table? Anything, any doubt? And don't be afraid that there are 92 slides. No, you know now how to read. Okay, 92 slides, I told you, for the first time, you may take 1.5 hours. But following classes, you won't need so much time. Okay. So anyone, anything doubt you want to ask me? So next class, we will be starting with a new chapter. So for periodic table, does anyone have any doubt? No doubt? It's either I am teaching way too good or nobody is listening. Either of the case can be happening. Okay, so that's all from my part. Ma'am?
Thank you, ma'am. Thank you so much, ma'am. Yeah, all right, students, join the next link for the 6 a.m. class.